Hello and good morning, guys. This is a machine learning session here, and I will be talking to you about my project. It's based on predicting the house prices, and I have used the famous data set, that is the Boston data set that is provided in the SQL library. As you can see on the screen, we have the code here. It's all written by me, and you can just go through the code and see. It's not a very difficult code. It's a very simple code. What I have done here is I have first of all loaded the data set, and then I have defined my features and the labels. Now features are the inputs and labels are the outputs, as in layman language, and then I am just printing the values of how many training samples and how many features I have. So I'm getting it as 506 training samples, 13 features. And now we have to first of all normalize our features. Right? So normalizing features, because to get everything in order, right? So the average is 0 and the standard deviation is 1, right? So because sometimes some features are much bigger than others and can have a stronger influence on the model. So that's bringing our. So, and the second thing is that we have to just take a particular k when we are dividing the data set into the training and testing data set, right? That's a different thing. Let's not go on to that now, but here I have normalized my features and given out my the data set, that is a training for X and training for Y, right? Data set, and and I'm using a placeholder value here because now in a TensorFlow library we have three types of data types, that is a placeholder, variables, and the constant. So constant value will be constant, variable will change, and placeholder will remain constant. In evaluation, it can also change, right? Can change while you are updating the values, right? Learning rate, and yeah. So as you know, the straight line equation is y equals to mx plus c, right? So in linear equation, the basic idea is to get the values of the m, right? So the slope y is equal to mx plus c, and the c intercept, right? So m and c values we have to get all. You might have looked somewhere that is y is equal to ax plus b also, right? So we have to get the values of a and b and then put in the values in the equation y is equal to ax plus b, and then get the value of y according to the x. And I also used now what my I have used cost function, right? So that is a mean square error, but tells us about the predictions, what predictions we have made, and what is the difference in the prediction we have made, and what is the actual prediction, what is the actual value. Yeah, and I use a gradient optimizer to just optimize my function. And then yeah, so cost was extreme. Basically, it is a frame that just stores the value of j, that is the cost function, as we are going in. Now I have defined for epoching brain 10,000 plus 1. So what does it mean? It's iterations, right? And then cost function will get updated after each and every for loop, right? For every iteration, cost function will get updated. Now what I have written here is that if epoch modulo 1000 equals to 0, that is after 1000 iterations it will get updated, right? So let's just check what I am getting in my output. Yeah, so I'll just press shift and F10. It's running. Let's see what is the output. We are getting an output that reached epoch 0, cost j is equal to 6.88, right? What is the cost function? Basically, what is happening here is that the cost function clearly decreases, and then decreases the value and stays almost, I think, constant. Yeah, it's constant, right? Now, what can we infer from the result is that this is a good sign, basically indicating that the cost function has reached a minimum, but that doesn't mean that our model is good or it will give good prediction. This tells us only that the learning has worked very efficiently and according to our plan, right? Yeah. And now, as we have features here, it is not possible to plot the price of the other features. However, it is helpful to get a feel of how good the model predicts the values. Right? So this can be done by plotting the target variable versus the observed one. Right. So this can be done in addition. Uh, and then yeah. Now the points. Now we can just see this is the value we are getting like can I check, getting like 21.95 in 1,000 US dollars, right? So it is good enough, right? Depends on the, yeah, so one can say it is good enough because you can say it is good enough because it depends on the problem you are trying to solve or the constraint and the requirements you have been given. So as I can see here, my cost opportunity is a good sign. So what it's trying to say is that our model is perfect. The model is working fine, right? And whenever I try to implement in a model, it is implemented very precisely. And yeah, that's it. And thank you for your time. Goodbye.